Now first let's understand this question. The number of ways in which an unlimited amount of funds be distributed among n refugees. What is the condition? The total money distributed should be a multiple of 4 and no refugee should get more than 4n minus 1 rupees. Right? Now let's apply this as a pure problem of multinomial expansions. So let the total money distributed be equal to 4k where k is a natural number, so that the total money distributed is always a multiple of 4. Then there is a second condition. No refugee should get more than 4n minus 1 rupees. So let the refugee identity of one refugee xi get rupees pi as his money. Then first refugee gets p1 rupees. Second refugee gets p2 rupees. Like that there are total n refugees. So can we conclude as the total money distributed is 4k, shall we say sigma r equal to 1 to n, the sum obtained by each of the refugee pr should be equal to 4k, right? And what is the important condition given? No refugee should get more than 4n minus 1 rupees, right? So that is also important to observe. Then the money received by each of the refugee pi should be between 0 and 4n minus 1. So now each refugee getting pi rupees and the sum of all the money received is 4k rupees. Then the required number of possibilities is equal to, yes, what does multinomial theorem says? Is the number of non-negative integral solutions of the equation p1 plus p2 plus p3 so on up to pn should be equal to 4k for different possible values of k as 1, 2, 3 so on up to infinity, because there is an unlimited amount of funds available, right? So which is again by multinomial theorem, what we are looking at is the coefficient of x to the power of 4k in, yes, each person got pi rupees, then it would be the coefficient of 1 plus x square plus x cube plus so on up to the maximum amount that a person can receive is 4n minus 1 rupees, and there are n such refugees. We need to find this coefficient of x power k for different possible values of k, right? Now how do we calculate, as k is a variable, how do we collect the coefficient of x power 4k from this expansion? Now observe the working here. Let's consider the expansion of 1 plus x square so on up to x to the power of 4n minus 1 raise it to the power n, right? This is a polynomial expansion having all powers of x power 0 to x to the power of 4n minus 1, and the whole thing is raise it to the power n. Then this expansion will have terms starting from the constant term, that is r equal to 0 to, what is the highest power? Yes, it will be 4n square minus n, and each of them will be in the form ar x to the power of r. And if you observe what is our requirement here, yes, we are looking at the coefficient of x to the power of 4k in this expansion. Then when we compare this one equation with 2, the required coefficient is for different values of k. That means we are looking at the coefficient of a4 plus a8 plus a12 plus a16, all multiples of 4 are required up to infinity, right? Now from the equation 2, how do we get the sum of the coefficients a4, a8, a12 so on up to a16 so on up to infinity? Yes, in equation 2, let's put x equal to 1, minus 1, I and minus I. So you'll get 4 different equations arising out of 2 by putting x equal to 1, then minus 1, then I and minus I and adding them. Yes, because we wanted the sum of the coefficients at an interval of 4 units. We have taken those values of x for which you get a plus or minus sign for different powers, so that only the terms of a4, a8, that is the difference of 4 terms is remaining, right? This is the procedure in multinomial theorem to get the coefficients of sum of the coefficients of a4, a8, a12 so on, and adding, what do we get? We get 4 times a0 plus a4 plus a8 so on up to infinite terms, and this would be equal to, when we put x equal to 1, what do we get here? Yes, there will be 4n terms here, so we'll get 4n raised to the power n, plus when we put x as minus 1, these terms will be alternate plus cancelling each other, leaving you with 0. Similarly, when we put I in the left hand side expression, that also alternate terms would be giving us 0, sum as 0, and similarly with the minus I also, so that is also 0. So what do we get now? Therefore, we got A0 plus A4 plus A8 so on up to infinite terms would be 4 power n into n to the power of n by 4, which can also be expressed as 4 to the power of n minus 1 times n to the power of n. But this is also having an additional factor of A0, but we need the sum only from A4, A8 so on up to infinity, because whatever we are distributing, we are not distributing 0 rupees, right? That sum is, the total sum distributed is always a multiple of 4, but not 0. So A0 is an additional term on the left hand side. Therefore, the required coefficient, that is A4 plus A8 plus A12 plus A16 plus so on, this would be equal to 4 to the power of n minus 1 into n to the power of n minus A0. But what is value of A0? Yes, that is a constant term coming out of this expression, which is equal to 1. That is 4 to the power of n minus 1 into n to the power of n minus 1, right? So how do we conclude this? Therefore, the total number of required possibilities is 4 to the power of n minus 1 into n to the power of n minus 1. What is the total distribution? It's a distribution of infinite number of amount as a multiple of 4, and each of the refugee gets not more than 4n minus 1 rupees, then the total number of ways of distributing this money is 4 to the power of n minus 1 into n to the power of n minus 1, which is presented the option 1, right?